So if I'm in main and I want to call a function called print, you can call function print if the body of function print was placed above function main. But if you implement function print below function main, then what you have to put above function main is the declaration of function print. You understand? In other words, the order in which you list the functions, like literally the order in which you put it on your file, matters. The functions you call must be placed above. So if I'm function A and I'm going to call function B must be listed above me. All right. So either the full implementation is above me, or you can have the implementation below yourself, but the declaration has to be above you. I don't know if that makes sense to you guys. Does that make sense?
Yes, sir.
Okay, so the only issue is that I'm surprised that the compiler did not complain about that, because this code is literally coming from like the authors of the book. So if there was an issue, I would have thought that that would have been resolved. In any case, that's what you guys can try if you don't see the menu popping up. Just declare function instructions, semicolon.
I tried that and it works, sir.
It's working?
Yes, sir.
All right. That's, uh, this is Barry White, right? Talking?
That's right, sir.
Right.
How did you know?
Damn it, Barry White is just trying to like impress these girls with his heavy voice, man. I know it. I know it, damn it. I know what you're trying to do.
I'm the one now. Why you call him Barry White?
Yes, dude,
Yes,
listen
sir.
to his
Well,
voice, man. If this guy doesn't want to
yeah.
do IT, he can now just like, all he has to do is learn how to sing. Or even if
Whatever,
not,
whatever.
he can work on those, like those people, like those hotlines where people are lonely, they can call you and then you can tell them, hey,
Yeah,
darling,
of
don't feel alone
course.
no
Don't
more,
know.
darling. Okay,
Yeah.
okay. Having said that, any questions? No. All right. We're gonna continue where we left off, but this time I'm gonna move pretty fast because I have, I think, I believe, I have fully exhausted the fundamentals. So now it's just going to be looking at how would you do this function? How would you do that? How would you do this? All right, and then we can follow along. I recommend. Again, I'm not gonna check your work. I can't check your work, and I don't have the interest to be honest. Right now, what the frig am I doing? Sorry. I'm going to just basically like we're going to talk about how would you do this function instead of just watching me do the function on the screen, right? I want you to try it. Write it, screw it up. All right, your goal should be to screw up writing these functions, but as long as you try. And I promise you, during that whole process of screwing it up, you're going to learn. But if you just watch me write these functions, I promise you, even if you say, oh, yes, that makes sense, you didn't learn a jack thing, you understand? So just try it. So the first thing we're going to do, we're going to come to this, and remember, I'm just going to quickly go over my analogy. If I have a list node class, this class is useless, right? By itself. If I just have this is a dumb class. All it does, it allows you to build a bunch of these. Who cares? Who cares if I have 1,000 of these, right? This does not mean that this is a linked list. It just means you have a bunch of list nodes, okay? Nothing special about this. What I need is for somebody else, some independent person, independent third party, to come and say, hey, you point to this one, and you point to this one, you point to this, you point to this. And in this way, this organization can now be considered to be a linked list. But themselves, by themselves, individually, they have the capability to point, but they don't know who to point to. Understand? It's like the pickup truck that I told you. A pickup truck has the hitch, but the pickup truck is incapable. A pickup cannot just reverse by itself and somehow attach itself to a trailer. A human being has to intervene and do that. So that entity, that human being that has to take the pickup truck's hitch and attach it to the trailer, the role of that is being done by class list. So for every linked list, I want you to listen carefully. For every linked list, a linked list can have 0 nodes, 1 node, 5 nodes, 1,000,000,000 nodes. A single linked list can have 1,000,000,000 nodes or even more. The size of a linked list is dependent upon how much memory your machine has, all right? But regardless of how many nodes a linked list has, a linked list only has a single list object, all right? That one list object manages all the nodes. That's what you need to, definitely implant in your head. All right. One list object per linked list. All right. One list object per linked list. Okay. Let me see how many people we have in this class right now. 48. Well, 47. Okay. So coming back to this, I said, what if we're inside a function main, and inside of main we had, so this is, shoot, man, this is tablet. I kill you. Hold on. Let's try it again. Create some space on this disk. All right, let's try it again. All right, so here, so this is, oh, hold on. What is this right now? Okay,
Almost there, sir.
almost there. All right. Okay, so main. So the first thing is I'm going to build myself a list object. But remember, list is not a regular class. It's a template class. So you can't just put the name of the class and then right next to it, you're going to put, right next to it, you're just going to put a name and go, oh, like that. That's illegal. All right? That's illegal. So what you have to do is, oh, great. You're going to have to put. Now, what did I just do? This just called the constructor for the list class. So let me just quickly go to the constructor for the list class. And here it is. Look at the constructor. Well, let's just backtrack. Just quick recap. How many data members does the list class have? How many data members?
2.
Two. First PTR and last PTR. First PTR and last PTR, right?
Right.
So I want you to remember this. Every time I tell you, if you were to cut open an object, what would you see inside? Your
Data
answer should
members.
always be data members, not member functions. All right. Just like I told you, if you had to get surgery for your knee and then the doctor cuts your knee, jump is not going to fall out of your knee, right? Run is not going to fall out. Those are functions that are part of you because you have bones, ligaments, tissue, blood cells, blah, blah, blah. So inside of you would be those things, the data members. Does that make sense?
Yes, sir.
So with the list class, since there are two data members, if I were to visually, this is my list object, and he has two parts. He has a first and he has a last. All right. Now, these I mentioned to you are pointers to list nodes. All right. These are pointers to list node. So that means this guy, first PTR, what can he point to? What if I did this? Let me show you something. What if I did this, right? What have I done in this line? What have I done in this line?
You're telling the compiler that to create this nodes of int.
But what is this? What is this? What is this, dude? What is this?
Is the name of the object.
What kind of object is this?
List object
A list object of what type?
of type int.
Of type int, right? And what is this?
Right.
What is this?
A node.
This is what is this?
List object.
A list object. So how many list objects do I have right now?
Two.
Two list objects.
Okay. Can I do this? Can I have this guy's first PTR point to this? So now if I were to draw Li2, right? He has his own first, he has his own last. Let's pretend Li2 is at location 100 memory and this guy's at location 9000. Can this guy point to this guy? That's the first question.
No,
Why?
because even though both of them are of type int, there are two different object names.
Object names. No, I'm asking you.
Okay.
Remember, this guy's a pointer, right? Can he
Right.
store? Okay, can I do this? Can I store the address of this Li2? Can he do that?
No.
Why?
It's not a self-referential class.
Okay. What else? What is first PTR? See, you guys have to understand this. What is first PTR?
A preferential.
What is first PTR? What is it? Look, what is it?
A pointer.
Pointer.
What kind of pointer?
Pointer to list node and
This
after
node.
A pointer to a list node. What the hell is a lie to?
Stop.
What is a lie to?
classes.
Object.
A list object. This is why I keep on bringing back this point, because you guys have to grasp this. List and list node are two separate things. A human being and a pickup truck are two different things. Do you understand? They're not the same thing. The human being controls a pickup truck. The list controls a list node. They're two different classes. They work together, but they're two separate classes. I'm looking at my list class, and my list class has two pointers. I'm asking you, what type of pointers are these? In other words, let's break it down. What can first PTR point to?
Pointer of this node.
List nodes.
First PTR can point to a what?
This
list
object.
node.
This
To
node.
a list node object. You understand? So is this legal for this dude to point to my li2?
No.
No.
Why? Explain to me what I just said. Why? Why is this not legal?
Because
They're not
list.
list node objects.
This is a list object. He is not allowed to point to list objects. If I wanted this guy to point to a list object, right? Like what I'm doing right now, if I wanted that to happen, I would have to take this out. You understand? Which would make this a self-referential class. But my point is, I would have to take this out and say, you can point to somebody just like yourself. Then this would be legal. But that's not what I'm trying to do. This guy can only point to list node objects. A list node object has two parts, but his parts are data and next pointer. A list has two different parts, first PTR, last PTR. So this is illegal. You understand? A list cannot point to another list. A list can only point to list nodes. Does that make sense? Let me check the
Sense.
messages, the chat to see if anybody has any questions, because I don't know what to do. Mute mics, yes. If there's any mic in here, please mute it. All right, but Mary's can talk, Joe's can talk, but all the people with name Mike need to mute themselves. All right, is that what you're trying to say, Zin? Because we don't like mics, do we? Nobody likes a mic. All right, if there's a mic in your life, get rid of that mic. Damn it, nobody likes mics. This man's single but got dad jokes. That's right, Zan. At least I got jokes. What do you have? All right. So let's continue. A woman. I'm proud, dude. I'm proud. All right. I'm proud. I'm proud. Hopefully, one of these days, you're going to introduce yourself to that woman. Because a woman in your fantasies is not necessarily an actual woman, but we're not going to go there. Zion, the lion with the good imagination. All right, back to this. Looking at this. So now I built myself this. And this is what it looks like, right? This is what it looks like. There's first and there's last. Now, when I did this, who got called? The constructor for list. So let's go to the constructor for list. What does a constructor for list do? Look at the code. What does a constructor for list do? Already out of time? Stupid. Just remember, guys, just re-click the same link. Re-click the same link. But anyway, not yet, not yet. When this thing actually runs out. What is a constructor for? What is a constructor what should a constructor do in general? Just speaking generally, what should it do?
Initialize.
And you have two data members. You have first PTR and last
Yeah.
PTR, right? So when you initialize a pointer to 0, right? If you have a pointer, when you initialize a pointer to 0, what are you actually doing?
No.
No.
It's null, but what does that mean though? Yes, it's null. True, but what does that mean? The meaning behind setting a pointer to null. What's the meaning behind that?
It's not pointing to anything.
Basically, I'm saying this little dude right now is not pointing to anything. That's what null means. All right? So right now, why would the constructor set this guy to null and this guy to null? Why?
So it doesn't point to any unknown parts of memory.
Okay, but also why? True. Yes, true. What you said is true, but there's another very important reason why these things are pointing to null right now. Who said Roy? Roy,
Like
you're
I point
correct,
to something
right?
else.
You just built a list. Do you have any nodes inside of your list?
No.
No. So how the hell would they be pointing to anything? You understand? You literally just built a list object. So obviously first and last should not be pointing to anything. You understand? It's only after you do insert. It's only when you start calling these insert functions that you start to add nodes to your list. But when you first build it, these guys should not be pointing to anybody. There are no list objects. Sorry, there are no list node objects within your list. So so this line produced that. You with me so far? Are you visualizing what's going on, right?
Yes, sir.
So now I have my list object, bum bum, they initialize to 0. I want to start adding stuff to this list object. So I know that there's a function called insert at front. And insert at front says, give me something of node type. In this case, because my list is of type int, that means automatically node type will also be of type int. So when I come here and I write li dot now, we know what the rule is, right? Whenever you call a function, go to that function. So with my list object, with this little dude right there, I said I would like to insert at the front of the list, right? And what this function wants is, he wants to know what value do you want to put inside of the list node that you want to be placed at the front. You understand? So remember, insert at front, his job is to build a list node and then with the value and then place that node at the front of the list. You with me so far? That's what insert at front should do. Build a list node and put that list node at the front. How many people understand that so far? Does it make sense so far? Everybody?
Makes sense, sir.
Yes, sir.
So, having said that, let's do that. So we're going to, again, we did this last time, but I'm just doing it again. So now, how would I do that? Well, if I'm going to insert this at the front, that means I need to first build myself a list node object. But let's visualize, well, let's do it. So the first line of code would be, let's look at it. Here. So this is the code for, can I move this thing somewhere else? No. Wait, ooh. Put this. Okay, I'm trying to move this thing. All right. So look at the first line of code. So this is my, I'm going to redraw my list object because I'm on a different slide. This is first, this is last, currently this, currently that. And then you did li dot insert blah blah blah, and you passed in a, right? And a had the value of 9. What's going to happen now? First thing that's going to happen is a will be passed and into this thing, correct? Now, if you notice, there's an ampersand there. What does that tell you about value? What type of parameter is value? There are only 2 types of parameters. Pass by copy and pass by reference. What type is this?
Reference.
Reference. What does that even mean? What does that even mean?
It is not passed by copy.
That value is gonna become A.
That is true. If it's passed by reference, it's not passed by copy. That's like
Um,
very true. It's like if I ask you, what is true? Well, true means it's not false, right?
You're able to
That's
change the
true.
value.
That is true, my friend. All right. So, what does it mean for you to pass something by reference? It means that the thing you give me, right? The thing you give me, in this case, what did I give him? A.
Value.
9.
A. That means value, if I need to visualize this, right? Value is now A. He does not have a copy of A. The difference is this, right? If I remove this, value gets a copy of A. So that means value would get a copy of 9. But when I put the ampersand, it means that value is now another name for A. So if you do something with value, you're literally changing the value of A. That's what pass by reference means. All right? Whereas if I did not have the ampersand, it means that whatever you do with value, you're actually changing a copy. So if I change value to 21, A is still 9. A is still 9. But because this is a reference, if you change value to 21, outside of this function, A now will get the value of 21. Does that make sense to you? You understand the
Yes,
difference
sir.
between pass by copy and pass by reference? Good.
Makes sense, sir.
Now, having said that, I just called insert at front and I passed in A. What's going to happen? Remember, every single time you call a function, the first thing that happens is the parameter gets created. So I'm going to draw the parameter. This is the parameter, and his name is value. And value is just another name for A. Understand? So this didn't actually happen. This was actually A. Value is now just referring to the same location as A. So this is what I have right now. Now, all of this is just this first line here. Now, what's the next thing that I do? I call function get new node. Do you remember this function get new node? Check it out. Let's check it out. This is this. What did I tell you about this function? This is a what?
utility function.
What else? What's another
I
name for this?
helper.
Helper, right? And it's because it's private. Now look at what get new node wants. Get new node wants a what? He wants a node type. And what is he going to return? He says, when I'm done, he's going to do something. We're going to see what he does right now. He says, when I'm done, what is he going to return back to you?
Pointer.
To pointer to
Well, this node
Let's node,
of what type?
of type
node type.
Which in my
int.
case is what?
Int.
Int. Perfect. That's what he's going to do, right? So now let's let him do his job, right? Let's find that function. So here, what we're going to do right now, right? Notice I'm currently inside a function insert at front. I'm currently inside of this function, and he just said call insert new node. And what did he pass to insert new node? This guy.
Value.
Remember, this is A, value becomes A, and you're saying call this function and pass in value. So let's make a little trip. Let's make a little trip, and we're going to go to get new node. 5 hours later. Get new node. Where's it? Here, this is get new node. Now look at get new node. What does he say he wants? He wants, in this case, a reference to an int, and this is called value, correct? Just so we can continue from where we were before, right? This is what I had so far. I had a variable A that contained 9. When I passed it to insert at front, value got created, but value just points to whatever A is because value is now A. When we come inside of this function, another parameter gets created, but remember, he doesn't get a copy of this. He also becomes this. So there's another value that's created. This value refers to this value, and this value refers to A. So All right. I don't know how the hell I'm going to give you a test in this class. All right.
So you will be using the lockdown something